Hello, everyone. Welcome to ProjectPro Industry Expert Sessions. I'm Binny, the co-founder of ProjectPro, and I have with me today Ajay, who has almost 2 decades of experience starting off as a decision scientist, data scientist, across the spectrum of SAS in the early days to R, Python, and currently on GenAI. Ajay is also a popular author of almost 4 bestseller books covering topics across SAS analytics, R, and Python. Ajay, thank you so much for spending time with us today. Welcome.
Thank you for having me, Binny.
Okay. So Ajay, just given your breadth of experience, it would be really helpful to hear your perspective since you have seen everything from SAS to R to Python to LLM today. What has really changed across the spectrum from both powerfulness and just ease of use of these tools? And what has really changed today with the LLM level of abstraction? That'll be very helpful to hear.
So there are 3 points that you have covered. One is power of the tool.
Yeah.
Second is ease of use of the tool, and third is abstraction.
Yeah.
And I'll try to cover all of them. So the SAS version which I used was SAS 8 in 2004.
Yeah.
And now SAS itself has evolved to SAS 9 and then SAS VIA.
Yeah.
And the programming languages, even though Python and R had been there for long ago, but around 2008 and 2007, R started becoming increasingly analytics language. And then around 2012, after Wes McKinney wrote Pandas, that's when Python really took off as a data science platform. And as of today, Python is the easiest coding tool to do data science in. But SAS is there, and SAS is a $1 billion company, and SAS is doing great.
Yeah.
And R is an increasingly specialized tool for high-level programmers who want a lot of statistics, or they want customized statistical packages. So there are some tens of thousands of packages in R. And so their tools are becoming increasingly easy to use. They are becoming powerful. The third thing is the introduction of cloud.
Yeah.
With cloud, as data exploded, computing power also exploded. So as data became big data, computing power also exploded to more than one machine at a time through Hadoop. And through the cloud, like Google Cloud, Azure, and AWS, which are the primary 3 leaders, we can increasingly channel a large amount of data into insights. And we can use whatever language we want to use. And particularly in banking, SAS is increasing. A lot of SAS is used in banking. But if you want to start from scratch, for startups, Python and R are used. So the tools are becoming easier, the tools are becoming powerful. The computing paradigm has shifted from the local machine to the cloud. And then you have paradigms in like machine learning, deep learning. Deep learning came about a couple of years ago. Even though it had been present for many years, but it started getting increasingly used a couple of years ago. And then now you have LLMs, which is the next level of advances in natural language text processing, NLTK. And so the holy grail is to do away with coding. You write a query in English and you get the insights in that, which makes it a challenge for data scientists, because data scientists had been positioned as people who could go to the data and give out insights to the business. But with the LLM, the business user need not depend upon the data scientist,
Right.
except that the LLM itself requires some level of expertise now.
Yeah. Understood. Okay, that's very helpful, Ajay, both touching upon how you see the paradigm changing and also the role of a data scientist changing. And that kind of, I have a follow-on question on that, which is if you could maybe elaborate on your definition of an end-to-end machine learning project, maybe everything from data collection, EDA, modeling, tuning, all the way to deployment. And if you could talk about which parts of that end-to-end life cycle are most amenable to being taken over by an LLM, where will we see the earliest parts of LLMs playing a role? That'll be very helpful, Ajay.
Okay, so it used to take several weeks to make a model.
Yeah.
But as of now, with LLM, you can do code generation.
Mm-hmm.
You can say, create an XGBoost model in Python for me, and the answer will come about in 30 seconds.
Yeah.
And what cannot be automated is something like data sourcing, from which data point to input, and data labeling, data versioning, what are quality of data, data pre-processing, imputing missing values. Should you replace them by mean or median? Or how should I deal with negative values or invalid values? Then the second part is feature engineering.
Yeah.
Feature engineering, you can create more variables, which is through things like get dummies or one-hot encoding or label encoding, or you can reduce the number of variables using in our step AIC, or in Python recursive feature elimination. You cannot do is select the top, create a model with 1,000 variables, and you can't say, okay, narrow down the variables to only 10 variables.
Yeah.
For that, you need a data scientist. So model training,
Yeah.
model evaluation are parts of things which require coding, but which also requires subjective analysis from a data scientist. Or if you're building a NLTK model, let's say topic model, then how many topic models should you build?
Yeah.
Or how many, if you're doing clustering, how many clusters should you create?
Yeah.
You need some subjective. Now, after you build a model, then you do model versioning to see which model is the best or how the model is evolving, and do the model deployment, and then do prediction monitoring to see things like data drift, or things like how the model is behaving as a period of time. Again, you need some subjective analysis. So I don't see the data scientist going away soon. I see the data scientists using LLMs to create code, and I see the LLM itself evolving to be a more accurate, less hallucinated version, and so it will assist it. It will not remove the data scientist. It will assist the data scientist to create a better model faster.
Yeah, makes sense. So since you mentioned the topic of hallucination, one follow-on question I had on that is, just given the last 18 months, the explosion of what has happened in GenAI and LLM, right? There is most enterprises I speak to, everybody wants a LLM strategy right now. Everybody's asking, where is my GenAI product? But there is a ton of confusion around what tools to use, what combination of that to use, everything from what foundation model for what use cases, what frameworks like LangChain to use. So how does one navigate through stitching together the right set of tools for a specific business use case and showing outcomes?
So I would say that you should. It is difficult for individual companies with a small analytics data science team to further add in Gen AI capabilities.
I see. Okay.
What you can do is you can partner with other IT companies which have a lot of people. They're training thousands of people on Gen AI.
Yeah.
and they can come up with, and then you can, there are some things which are not going to change. You will need LangChain, you will need RAG, but you'll need guardrails, and you'll need vector databases. But how do you use a LLM for my own company data without my company data going to the LLM? So that nobody can, search on ChatGPT and find my company data on it. So how do I do this? So this space is still evolving, and tools are also evolving. And as tools will come in, the space will evolve. You will need more specialists, GenAI specialists, and data scientists themselves would need to upskill themselves in GenAI.
Understood. Makes sense. And one of your core expertise in your current role and the previous role has been to kind of ensure just effective integration and delivery of data science solutions into enterprises. So that sounds like the MLOps deployment end of the end-to-end project lifecycle. So it'll be helpful to understand, how do you define this whole concept of MLOps? Is that a separate role by itself, or is that part of the regular data scientist role? How is that evolving in the industry? It'll be great to get your perspective.
So in an ideal world, MLOps should not be a separate world skill, but the fact is, MLOps skill set is not present in each data scientist, and so they need to learn that. And not every data scientist can use Docker or Kubeflow, and they don't need to. Also, they can deploy the model and using Vertex AI or Azure. And so it depends upon the case, which cloud you are using, which are you using MLflow, or are you using AutoML? How do you track your models? How do you keep so which software are you using for tracking your models? Which software are you using for tracking your predictions? Which software are you using for deploying your model? So the basic is Flask, but in the real world production scenario, Flask is not a production model versioning. So you can use something like Fast API and GUnicorn or Unicorn. And the skill set evolves from the life cycle. All this is part of the same life cycle, from data to model to deployment to predictions. So data, model, deployment, predictions, same life cycle. Just further down the line, you need to do more model tracking and model deployment and predictions. Earlier on, what happened was, sometimes we had a distinction between data engineers and data scientists. So data engineers used to be responsible for pipeline of data and maybe even the model deployment. And while the data scientist was content just building the model. After getting the as good a data he can get from the data engineer. I think the two will converge from data engineering, and data scientists will combine. And I think there will be a better synergy between the two of them.
Very interesting. Okay. And do you think, as this evolution of the role and the tool stack takes place, how will companies decide between building all this internally, versioning and all of that, versus using vendors or tools like Weights and Biases, True Foundry, MLOps platforms? How does that decision get made? Build versus buy?
It's very difficult to build a cloud. You can buy a cloud and create software as or applications on top of it. So it is very difficult to build LLMs. You can create applications on top of LLMs. So building is a difficult decision. What is not a difficult decision is keeping your integrity and confidentiality of your code base in machine learning or in deep learning or in GenAI, you want your customized IP to be, that is where you need to build. And when you need to build it, you have to put in more resources than when you need to buy it. When you buy it, it's very easy to go to Vertex AI, build an auto ML model, and create a pickle file, deploy the pickle file. And suppose you want to do the same thing as in building it, you'll have to create a machine learning pipeline, and you will have to deploy it using Flask or Fast API. And then you'll have to keep that server on all the time. So it's a discussion which needs to your existing infrastructure, and how much infrastructure are you willing to incrementally purchase, and how much are you going to invest in it, how confidential is your data, what compliances does the regulator impose on you. For example, banking, financial services have much greater regulation and compliances, so they might be more prone to building solution. Whereas something like e-commerce, they might be more prone to building their models and deploying them on the cloud.
No, that makes sense. I think that's very well structured. You're saying build versus buy is kind of proportional to a combination of what you define as your IP, what your regulatory environment looks like, and the effort and cost to fire up something like this and get it going.
Right.
Okay. And, this has been very helpful so far, Ajay. I mean, we've been talking about these things in fairly conceptual terms. Is there a industry use case you can think about that you have worked with recently, obviously confidentially, without names, that you can describe just to put some color to these concepts and the end-to-end project, what that really looks like? That'll be very helpful.
I had a previous opportunity in which we are building machine learning models. And we had to deploy the models. So the data was in MongoDB. So we used to take dumps from the MongoDB and then put it in Python and put it on Vertex AI. And then whatever output you're getting, like accuracy, precision recall, or ROC curve, or feature importance curve, we were putting in our software. So deploying that solution in the Vertex AI cloud was not really, because we're building a customized solution for it. All right. But compared to this, another use case was when we were building a machine learning model to predict sale of digital sales for a retail-based client. And there we built a model, and because it was a retail-based client, the number of SKUs was a large amount, and they were all correlated to each other. So we had something like 150 variables. So we had to narrow down the number of variables, and the accuracy also dependent on how well we did feature engineering on it. And then we deployed it on the cloud, on Google Cloud.
Understood. And the output was basically ingested. Was it a dashboard that somebody saw, or was it ingested into a client's end product, the final output, or?
The output was a dashboard.
Okay.
But the model was a pickle file, dumped into a pickle file, and the pickle file was deployed. And then it was used for scoring of the model for fresh data.
Understood. Got it. And in a scenario like this, Ajay, how does this, because retail is so fastly changing in terms of macro conditions, customer sentiment, and things like that, no? How does a model like this stay updated with fresh insights and data coming in? Is that
What you're talking about is data drift.
Yeah.
And how does you counter data drift? Well, you have to monitor the data, and that is part of MLOps. We have to monitor the predictions if the predictions are making sense. So you have the predicted value and you have the actual value, and you have the root mean square error. And if the error becomes large, then beyond a time you need to rebuild the model.
Understood. Got it. Now, for a aspiring data scientist or a data scientist who wants to start working on MLOps kind of deployments, in this entire use case that you mentioned, right? What are your suggestions for what kind of skill sets do they need to pick up and the best go-to sources for these kind of skill sets for somebody?
So some of the skill sets that I have picked up, and there are a lot of skill sets, are things like ML flow.
Yeah.
And auto ML. You can even build a ML flow integrated model in PyCaret, which is a Python auto ML package. There are other auto ML packages like Keyport and H2O. And then in cloud, I was Azure certified and Google Vertex AI certified. Certifications are a good way to learn about the cloud. And some people also go in for learning about Docker. But I don't think it's data scientist is necessary for a data scientist to learn about Docker or Kubeflow, Kubernetes. So ML flow, auto ML, cloud, these are the minimum. And additional Docker, Kubernetes, deploying. And deploying across Flask or Fast API. And learning about security, how to make your model deployment safe and secure.
Yeah.
So that is also part of it.
Yeah. Okay. That is helpful. And do you think in the world of LLMs and non-LLMs data science work, MLOps, the concept of MLOps remains the same? Because I'm thinking in the world of LLMs, as long as you're using something like OpenAI or Azure, the foundation model is there, the vector DBs are there, the embeddings are all there. Is there so much of an MLOps role in a world like that? What are your thoughts on that?
I think I heard the term called LLMOps recently.
Okay.
So you could do basically what is MLOps? It is DevOps, principle of DevOps combined with machine learning.
Yeah.
So similarly, you can do principles of DevOps combined with LLMs and come up with LLMOps.
Yeah.
And you can build in applications and you can track and monitor the applications. You will definitely need GenAI skill set of the future for the data scientist, and you will definitely need MLOps.
Yeah.
It is not enough to just learn about data structures and Python coding and doing model.fit on sklearn. It is quite easy, and as space itself for data scientists is facing a lot of competition with a lot of people studying data science and entering this field.
Yeah.
The skill set has to be differentiated.
Yeah.
And I think the differentiation can come with you learn GenAI and model deployment and MLOps.
Right. Got it. And just finally, before we wrap up, Ajay, what are your predictions for just emerging GenAI use cases for enterprises? I guess we all know about the summarization and I guess the generative part of use cases that we have seen quite a bit, chatbots and things like that. But do you have any predictions for in 2024 or 25? Powerful emerging GenAI use cases and inside enterprises that will show ROI outcomes?
Yes, I think so. That code generation is an use case where LLMs could be used. That will be disruptive to the IT industry, not only in India but worldwide. Because your earlier business model was you used to take, let's say, a month or 15 days or 3 months, 6 months to build a code base.
Yeah.
And you used to bill per the rate of every hour on top of that.
Yeah.
Doing LLMs, you will be able to build it much faster.
Yeah.
So if your business plan is billing on the rate of every hour,
yeah,
number of hours is going to shrink.
Yeah.
That is, so code generation already, I forgot the name, code generation LLM came about.
I think Devin.
Devin, you're right. Devin.
Yeah.
Got it.
Yeah.
Devin has, so I see better use cases for Devin, and I see ChatGPT and Copilot also. Also, code generation is an easier use case than the general text prediction use cases. That it's, for example, which Google has found in Gemini, predictions tend to be biased. When code generation, the code is not biased because the code is relatively fixed. It's a fixed quantity compared to just about anything which you input as to a chat GPT or LLM.
Yeah.
So one is code generation. Yeah. Second, I would see an evolution in the tools of RAG, retrieval augmented generation. Yeah. I would see customized LLMs being deployed across companies. So if you are a company and you give it all the emails, like you used to do it for Enron database for machine learning. But let's say I have an existing company and I want to predict sales based on the emails of the company. Yeah. Then that is a use case for a LLM, which normal machine learning will not be able to do. And but the tools will evolve. The current tools will not be sufficient to do that. Yeah. And also the providers. Microsoft is a great example of somebody who is both highly into LLMs as well as offering enterprise solutions based on LLMs. Yeah. So whereas OpenAI is just giving you the LLM, but it's not giving you customized LLM for your company. Yeah. So I think customized LLMs would be the second prediction. Okay. And the third is training in LLMs and training in generative AI, we should really take off. Okay. So today, as a data scientist, you learn scikit-learn, you learn Python coding. Yeah. But tomorrow you will need to learn GenAI also. Yeah. Understood. Okay, that's very helpful. There are three predictions. One is code generation is going to fundamentally disrupt, I guess, software outsourcing service industry. Second one is, RAG-based approaches to custom build LLMs for enterprise use cases is going to take off. And third, upskilling professionals on GenAI and LLMs is going to be a big deal. Right. And on the third thing, if I can ask one final question, do you think that upskilling professionals in GenAI LLMs will take the same approach as earlier enterprise upskilling, like Pluralsight, Coursera, Udemy, Udacity, or is there going to be a different approach to that, do you think? I think there will be a combination. First, you will have customized trainings through Udemy. I think Udemy got acquired by Accenture recently, right? Udacity did. Yes. Yeah. Right. Yeah. So you'll have customized trainings, Coursera and all that. You'll have certifications. Certifications is a big chunk of the training business. And then you will have more and more projects. And people who are trained will get deployed on the projects. Yeah. And some of the people who are working on the projects will contribute to open source repositories and further enhance LangChain, RAG, Ragas, MLflow, and all that. Yeah, perfect. This has been fantastic, Ajay. I mean, lots of
download for us on everything from the evolution from SAS to LLMs, how MLOps differs in the LLM world, and what career skills somebody needs, and your predictions for this year and next. Thank you very much for taking time to do this.
Thank you.